All right, so now we got to find the measure of angle K. So angle K is 4x. Uh-oh, didn't do that. Angle K is 4x, so we're going to plug in a 16 for x. So we're going to take 4x, but instead of putting in x, we're going to plug in 16. And then just, that's how we're going to figure that out. So let me scooch that over. Okay, so this is the measure of angle K. All right, just making sure we have all that written down. And that would be 64 degrees. All right, go ahead and try number 8. Remember, 180 rule. Actually, you know what? Disregard. You don't need the 180 rule for this. Let's do this one together. Or let me start you off on this one. So we're supposed to show the value of x. So we got those two that are the same. So this angle, I know they don't look the same, like the numbers don't look the same, but this angle is the same as angle R if those two triangles are congruent. So what you're going to do is set this up like this. And then we're going to do the same thing. If you don't know how to solve this by hand, you can use NSolve. So I'm going to go back to my calculator, go to menu, algebra, numerical solve. We're going to type it in. Type that in correctly. And then don't forget your comma X. Enter, and we get 58. So X equals 58. So use your Inspire calculator to solve the equation if you do not know how to solve the equation. Okay. Number 9, provide a counterexample for the following. If a number is a perfect square, then the number is an even number. All right, so this is an untrue statement because 3 squared equals 9, and 9 is odd. So this is a perfect square, but it's odd. All right, go ahead and try number 10. Number 11, identify the figures in the image that are spherical lines. So I'm going to highlight them real quick. All right, this one right here is a spherical line because it's a great circle. And a great circle is going to have a center that's the same as the center of the sphere. And that means this one is also a great circle or a spherical line for the same reason. It has the same center. So B and C are spherical lines, which are also called great circles. All right, can spherical lines be parallel? Explain why or why not. Spherical lines cannot be parallel because they are great circles. All right, is there enough information to prove the triangles below are congruent? Yes. All right, so I know you see here that we have two angles, right? So we have angle TRV, which is congruent. So this angle right here, TRV. TRV, that's this angle. And that's congruent to angle SVR, which is this angle right here. All right, and then also angle TVR is this angle here. and that's congruent to angle SRV, which is this angle right here. Okay, so we have two angles, right? So that's an angle, that's another angle, and there's a side between those angles right here. Boom. RV is congruent to itself by the reflexive property. All right, so that would be, and that's the side. So that would be angle, side, angle. So triangle TVR is congruent to triangle or SRV by angle, side, angle. So again, the answer here was yes. All right. Card number 14. Number 15, is there enough information to prove the triangles below are congruent? Yes, but let's specify which triangle. So triangle XWA, is it congruent to triangle, what is that, YZA? And that's what we're trying to figure out. And the answer is yes, there's enough information. If you look right here, you will see the side, an angle, and a side. Okay, so yes, I don't need the question mark. Those are congruent by side, angle, side. Go ahead and try number 16. Number 17, suppose PT is congruent to RS. What information do you need to conclude that this triangle, triangle PTS, is congruent to RST using the SAS congruence theorem? All right, so I'm going to start by drawing these separately. Try that again. Okay, great. All right, so let's just say this is RST and this is PTS. We already know these are congruent because we just marked them. We know these are congruent because it's literally the same side by the reflexive property. So we got two sides that are marked congruent. The information that we need to prove side angle side. So we know that side PT is congruent to side RS. We would need angle T and angle S to be congruent. And we got TS is congruent to itself. So that's our side angle side. So again, we would need to prove that angle, or we would need the information that angle T is congruent to angle S, or we could call this angle PTS is congruent to angle RST. So you could write it like this, or you could write it with three letters. All right, let's give number 18 a go. Number 19, suppose triangle ADB is congruent to triangle ACE and that DB is congruent to CE. What information do we need to conclude that the two triangles are congruent by SAS. Okay, so real quick, let me just draw these separately. All right, so that would be A, that would be D, that would be B, that would be A, that would be C, that would be E. And the information given stated that DB is congruent to CE. And we know that A is congruent to itself by the reflexive property. So we need side, angle, side. All right, so to get side, angle, side, we already have a side here. We have an angle over there, but it's not even close to the side. So honestly, we would need, okay, so this side is congruent to this side. So we would need to know that these two angles are congruent, and we would also need to know that these two sides are congruent. That would prove angle side, side angle side rather. So that's one way we could do it. Another way we could do it, sorry about that. Another way we could do it would be to ignore that side and then just focus on this angle here. And then we would just have to prove that the sides that include that angle are congruent. So those two sides. Okay, so I'll just use that one. It's easier to write down. So we would have to also have the information that AD is congruent to AC and that AB is congruent to AE. Okay. Suppose that AD, okay, so same figure. We're trying to conclude that these are congruent using angle side angle. So we got, again, if I draw these separately, this again would be A, this would be D, this would be B, this would be A, this would be C, this would be E. And this time we don't have any other information except for this. So we know that angle A is congruent to itself. So angle A is congruent to itself by the reflexive property. All right, so to prove angle side angle, we need a side because this is our angle right here. So now we need a side and another angle. So it really doesn't matter, but let's say that angle, side, sorry. Let's say we use these two sides. So that would mean AB is congruent to AE. And then for the next angle, we would need this one and this one. So angle ABD would have to be congruent to angle AEC. So again, angle ABD would have to be congruent to angle AEC right there. So these two bits of information could be used.